Welcome friends, hope you are alright. As promised in the earlier video, today we are going to see a topic known as logarithm. Okay, this is one of the most important topic which is helpful for not only the class 11 student but also for the class 9 student of ICSE board. They also do have this, so I will keep in mind while teaching this algorithm with teaching this logarithm chapter that it should be easy to understand for the class 9 student too. So let us start. Logarithm. First, let us understand the definition or the formal definition of logarithm. If a, b, c are the three real numbers such that a not equal to 1 and a to the power b equal to c, then b is called as the logarithm of c at the base a. This is written as log c to the base b. Means if a to the power b and equal to c, suppose a to the power b equal to c, where a is not equal to 1, okay, then it can be written as log of c to the base a equal to b. It can be written as log of c to the base a equal to b. What it is called? Log of c to the base a is equal to b. Okay. Now before going further, let me tell what does a here. What is a here? A can be a given value like 5, anything, 6, 7, 1, 2, 3, 1, 2, 3, anything, okay? If it is not given, if a is not defined, a can be of two types. That is, a can be 10, a value can be 10 and a value can be e. It depends if a is used in algebra portion or it is used in different means calculus portion. If log is used for calculus, for calculating any for doing a calculus sum problem, then you should use the base as e. And if it is given as a algebraic problem, then the base should be 10. Okay. Now let us see the graphical representation of log. If a's value is between 0 and 1, the graph looks like this. This is the path in which the graphs move. As we can see, it is a decreasing function. And if a is greater than 1, it produces an increasing function. Okay. Now, let us understand some of the properties of log. Okay. Log 1 to the base a is 0. I have explained here how we can do this. See, we know anything to the power 0 is 1, right? And if we take log, then log 1 to the base a equal to 0. Okay, how I have attained this from this? As I have discussed earlier, see, a to the power b is equal to c, then log of c means this one to the base a equal to b. For attaining this, sometimes it also become difficult for me. So I have remembered it like this. I would remember it earlier like this. That if we push a this side, then b comes above it, right? Means if we push a this side, it comes a to the power b, and here is left c, right? So we can attain like this. Means suppose we are pushing a this side, then the b goes above, right, and the a comes here, so a to the power b, and here remains c. So similarly like that, log of 1 to the base a is 0. Okay. Now log of a to the base a means when this and the base value is same, it will always give 1. Why? Let us see an explanation. If a to the power 1 is a, then log, if we take log of a to the base a is also 1. Now next property. If log of a to the power x base b means here the value here there is a power of a, then the x value comes at front, means it becomes x log a to the base b. If the power is at the base, right? Means a log a to the base b whole b to the power x, right? So the x comes down. Log a to the base b we can also write as log a by log b. Here it is to be noted that this base, when we are dividing it like this base should be same. If log ab to the base x, then we can write it as log a to the base x plus log b to the base x, so and vice versa. Here we need to note another thing, that here the base is same, so here the base is same, right? Similarly for divide, for multiply we need to write plus, and for divide we need to write minus. As we know, multiplication means repeated addition, division means repeated subtraction. You can remember it like that. Okay. Now log of m to the base a is equal to log of m to the base b into log of b to the base a. How? See, log of m to the base a can also be written as log of m by log of a. How? By this property, by seeing this property, right? Log of m by log of a. And as I have nothing written here, it means that I have taken to the base 10, which I have discussed earlier. If a is not mentioned here, then a can be 10 or a can be e. So here I have taken the algebraic value, so I have written 10, and if we take the calculus, we will go for e. A can be anything, means I have taken 10, it can be e also. The property will hold for that also. So if we multiply and divide log b both side, then it becomes log a m to the base b to the base log b into log b by log a. So this can be written as, so this is written as log a to the base b. Similarly this is written as log m to the base a into log b to the base a into log b to the base a. I think you have understood this. These are some of the easy properties. Another property is, if a to the power log b to the base a, here it is a power, okay? Here it is a to the power log b to the base a, and if you can see here a certain thing, that this power, okay, and this base is same, right? So it will give a result as b. Why? See, x is equal to log a base b, then I have told you push b this side and it will become b to the power x, right? So it will become b to the power x equal a equal to b to the power x. Similarly, if we take a to the power log a base b, and if we take, if log b to the base x is x, log b to the base a is x, if we take, then it will result to b. Now the next property is log a to the base b is equal to, we can write it as 1 by log b to the base a. Means the reciprocal, here the base and the value will also get inverted, okay? This property we don't use most commonly, but I have written here if it is useful to you. A to the power log b to the base x, then we can interchange this one, this one and the exponent and the base one, right? So here we can write b to the power log a to the base x. There are many more properties of log, like for the inequalities. We will discuss it in the further videos. Till now, you should revise up to this. I will provide the PDF of this notes in the description. You should revise up to this, and I will today I will also solve some problems, near about 12 to 10 to 12 problems, and also give assignment on this, okay? You should try to solve them. Now here I have given a note. Let us see what is the note here, okay? Suppose if a to the power x is equal to minus m, where a is greater than 0 and m is greater than 0, then the value of x will be imaginary, okay? The value of x will be imaginary. Therefore, the logarithm of a negative value is imaginary, okay? So that is why the log value, we say if we take x is equal to log b to the base a, so we take b value as greater than 0, okay? When b's value is 1, it will give 0, okay? It is not an indefinite. And when b's value is less than 0 or equal to 0, it will give a imaginary value. As b's value is equal to 0, it will lead to infinite value. So logarithmic value of a negative number is imaginary. I think you have understood all the properties. Here, along with the basic definition of logarithm. What is this base called? How can we define the base? And also the graphical representation of it. Now we will continue with some problems. Now this is our first problem. We have to find the value of this. Okay, for this type of problem, our first initiative should be that we should find the LCM of this value. Okay, 1728. Okay, we can write it as 2 to the power 6 into 3 to the power 3. If you find the LCM of this value by doing like the 1728 and with 2, 3, 4, now it will give the result of this 2 to the power 6 into 3 to the power 3. Okay, now how to solve this problem? It's a very easy problem. Suppose let us take that this value to be x. Okay, now as I have told, push this, means it becomes 2 to the power 3 whole to the power x. We are changing it to an exponential value. From log we are changing it to exponential value. Okay, now 1728 can be written as 2 to the power 6 into 3 to the power 3, right? And here it is 2 to the power x into root 3 to the power x, right? So 2 to the power 6 into, I can write it as root 3 whole to the power 6 equal to 2 to the power x into root 3 whole to the power x, right? So x values result to 6. This is a very easy problem. I think you can understand it. Okay, now here comes the next problem. We have to prove this value as 1. How? Let's see. First, whenever you get any logarithm problem, this big numbers you should simplify it to the least multiples. Okay, so 16 I can write it as 2 to the power 4, right? And here as there is a power, let us see the properties. When there is a power, we are when there is a power at a to the power x, we are writing x at front, right? So here the property is same. We are taking 4 here. In the next step we are taking 4 here. I think there is no problem now, right? And we know log a to the base a is 1, so this value changes to 1, right? So what is the remaining now? Log 2. Similarly, we can write log 4 as log 2 to the power 2. Similarly, we are writing this here according to the property, and this gives 1. Okay, what is the remaining here? Log 2 to the base 2, and it will give 1, so it is proved. Very easy problem, right? I think you can understand it. Now next we have to find the value of this. See, we know 1 by 81 can be written as 81 whole to the power minus 1, right? So we will write here, we are converting 1 by 81 to the whole to the power minus 1 and this 27, right? So we are taking minus 1 at front, so the result comes 81 to the base 27. We have to minimize the value, right? So 81 can be written what? It can be written as 9 square, right? 9 square is 81, or what else it can be written as? It can be written as 3 to the power 4, right? I am writing it as 3 to the power 4. Now 27, we can write it as 3 cube, right? So here it is 4, we will take it at front. So minus 1 into 4 log 3 to the base 3 cube, right? Now here I will use another property. See, when there is a power with the base, we are taking it 1 by x, right? We are converting the base to 1 by x. Similarly, we will do here. What we will do? Here it is 3 in the base, right? We will convert it. So here we are taking 3 and we are converting it to 1 by 3, right? And the result is log 3 to the base 3. As we know, this will result to 1 as log a to the base a is 1. So the final result is excuse me. So the final result is minus 4 by 3. This is our answer. Very easy, right? Now next, it is a little bit different problem here. There is a little bit different problem in this case. Okay, we have to, in this case, this equation is given and we have to find x in terms of y. Okay, what we have to find? X in terms of y. See, whenever you take any single whenever you see any single value here in this equation, in any logarithmic equation, as we know, 1 in log 1 can be written as log a to the base a, right? As we are taking here the base is 10, we can also write it as log 10 to the base 10, right? No problem here. So 3 can be written as 3 into 1, right? And the rest is the same. So as I have told, 1 can be written as log a to the base a, or here we will write as log 10 to the base 10, as here there is a base of 10. So we are taking as log 10 to the base 10 into log plus there is log x to the base 10 is equal to 2 log y to the base 10. When we know that from there is a 3 here, we can take it to the power of this, right? By which property we are taking it? We are taking it by the by which property we are taking it? We are, see, we are taking the vice versa of this. In this case, the 4 we are taking at front and the vice versa was to the power 4, right? So here we are taking this 10 to the power 3, right? We can write it here, plus log of x to the base 10 is equal to, similarly we can write here y squared to the base 10. No problem. As we know, when there is a plus sign, means as we know, log of a plus log of b, we can write it as log of a into b. Please see the properties once again. So we can write it as, by using that property, we can write it as x into x, and here we can also, we can see the base as same, so we can convert it to like this, and it is y square to the base 10. I think it's okay till now. There is no problem, right? So after this, what we will do? So I am writing here what I have used here. If you did not understand this, how I have changed from this to this, I have used this property. I think I have told this in the properties, right? So I have used this property. So what is the result now is obtained by using this property? Right? The result obtained is this. So here it is base 10, here it is base 10. Now if I convert this to an exponential function, suppose I am taking this base 10 here, means exponential function 10 to the power, we are converting it to 10 to the power form, right? Exponential form. Now in this case I have told another property that a to the power log b to the base a can be written as b, right? I have discussed this property along with the proof. I think you could remember it. So in this case similarly it will give us y square, right? Now what was the problem here? X in terms of y. So we have to write x equal to 10 to the power minus 3 into y square. This is the result. I think you can understand it. It's a very easy problem, right? Here we are using multiple properties. We are mixing up the properties and using it. So it may be difficult for the beginners. You should practice it. You could practice these problems once again at your home and you will understand it very easily. Okay. Now let us see the next problem. What is the next problem here? We have to find the value of x. First, we can change it in exponential form. By saying this, what is the first thing we are getting in our mind? We can change this to exponential form, right? So as we know, for finding x, we have to move x to one side of the equation. We have done it in linear equations, right? We have to move it to one side of the equation. So for doing that, we have to eliminate this log. So how can we eliminate this log? We can eliminate this log by taking it to exponential form. Okay, so the exponential form occurs like this. If you remember, push 7 this side and it will come to square. It will 2 will move up, so it will become 7 square, and the remaining is 2x square minus 1. Now it is easy, right? So 7 square is 49, and here minus 1 will come here plus 1, so it will come to 50. Now x square is equal to 25 and x equal to 5, right? So the value of x here is 5. It's a very easy problem. Now in this case, the question is that we have to convert this into single logarithmic. Single logarithmic means there should be only one log function. How can we convert this? See, as I have told in my previous example, that when there is a number, we should convert it as 3 into 1 we can write it as, and here 1 is taken as log 10 base 10. Similarly we will do here. See, here it is 1, right? And here there is no base. No base means we are taking the algebraic value for now. Okay, so the algebraic value becomes log of 10 base 10, right? This is the value now. Okay, if we take 2 here and similarly 3 at the upside, 3 upper, means we can write it like this. I think there is no problem till now. Now see, when there is a minus sign, we know we should divide it, right? So we are dividing it. And when there is a plus sign, we would multiply it, right? So our answer is this. We can simplify it, means we can write it here 5 into 5 and 5 to the 10 divided 2 to the power 4 by 5. So you can do it on your own, right? So I think you can understand it like this. Now, what is our 7th question? Here we have given if log to the base 10 is equal to a and log of 3 to the base 10 is equal to b, we have to express 60, log of 60 in terms of a and b. See, first I am taking LCM of 60. I have told that if you get a big number here, you should LCM it and take the smallest multiples, right? So we can do it with 2, 30, again 2, 15, again 3, 5. Right? So what is the log value now? Log of 2 into 2 into 3 into 5. Now what will most of the student do wrong here? Let me tell you first. Okay, that see, Most of the student will do it as 2 square into 3 into 5, and for multiply we can write it, we will get this, right? Log 3 plus log 5. This is the property, like when log of a into b, we can write it as log of a plus log of b. Similarly, log of a into b into c, we can write it as log of a plus log of b plus log of c. I think you can understand it. Okay. C, and 2 square, it is a, means if we take 2 here, right, we can take 2 here from here to here, so it will give 2a plus b plus log 5. And in the question it was given that it should be only in terms of a and b, so here we are getting an extra value of log 5, so this is the wrong answer. Okay, from here what should we do? So this is the wrong answer. From here what should we do? See, here we are remaining with log 5, right? And here the base is 10. If we could give bring here 10, then the value will be 1. There will be no problem now. See, I can write it as log 2 into 3 into 2 into 5. I can convert it like this. This is the same, but I have changed only the placing of 2, right? It is 2 into 3 into 10. Now similarly, I will give log 2 plus log 3 plus log 10, right? And here it is the base 10, so this will result to 1. So it is a plus b plus 1. Why a plus b? Log 2 value is known as a, log 3 value is known as b, and log of 10 to the base 10 is 1. I think you can understand it. Okay. Next problem. Please pause the video here. I have told many problems like this till now. 2 or 3 problems I have discussed till now like this. So it is, I think it is an easy problem. Pause the video, try it yourself. If you can't, see the solution. Okay. Similarly, as I have told, 1 we have to change it, right? What we have to change to? Log of 10 to the base 10, right? Because here the base is 10, we are converting it to 10 to the base 10. As 1 can, log of a to the base a is 1, so we are converting it like this. So it is 250 base 10. Now we can write it here, means log of x square to the base 10. This 2 can be taken here. Right? Here there is plus, so I can multiply it, I can write it in a multiplication form. I think there is no problem. Now if we have to eliminate log for finding x square, right? We are converting into exponential form. If we convert this to exponential form, we are taking 10 to the power log of 250 to the base 10. Here this value and this value is same. We are using that property, a to the power log b to the base a, it will give b, right? Which property are you using? A to the power log b to the base a will result as b. This property we are using here, and it will result to what? 250, right? According to this problem, and it is x square into 10. So I am eliminating 0 here, so x square is 25 and x is 5, right? X is 5. So this is the result. So let us go to our next problem. Our next problem is this one. It is similar to this problem, right? It is somewhat similar to this problem. What is the problem here? We have to find this in terms of m and n, right? See, first log of m to the base 3 is equal to x, right? And we can write it as m is equal to 3 to the base x. Similarly, log of n to the base 3 is equal to y, right? So we can write it as n is equal to 3 to the power y. There is, I think there is no, sorry, I have some, I think there is a problem here. It will be 2, I think, not 3. N is equal to 2 to the power y, right? Now if I solve this problem, it is like this, and as we know, if there is a minus, we can write it as division form, right? and here there is a plus, we can write it in a multiplication form. Sorry, there is 3 only, it is 3 only, I've done it wrong, it's 3 only, no problem. Now 3 to the power 1 is 3, no problem here. 3 to the power x, we can write it as this, like this, I think there is no problem. And 3 to the power 2y, we can write it as like this. Now this value, what it is, m, right? So we can write it as 3 into m cube, no problem. And 3 to the power y is n, so we can write it as n square. So this is our result. Very easy problem, right? Now this is a little different problem, little but different. Here L, M and N value is given, so we have to find the value of L plus M plus N. See, for doing this problem, let us first change the L value. See, in this, here the base is BC, CA and AB. Here there is missing of A, here there is a missing of B, here there is a missing of C. So if we multiply and divide A here, multiply and divide B here, multiply and divide C here. So let us check what is the result now. Here it is like this. So we are multiplying and dividing A here. So what is the result now? Log of A cube by ABC. I think there is no problem. Similarly, for M value, it will become log of B cube by ABC. I think there is no problem. And similarly, for N value, it will change to log of C cube by ABC. I think now also there is no problem. Now, what we need to find? L plus M plus N, right? So L value now is log of A cube by ABC. M value is log of B cube by ABC. And N value is log of C cube by ABC, right? So after this, what we will do? See, what is our problem now? It's like this, right? And we know if log of A divided by B can be written as log of A minus log of B. So we will be using this property here. We can write the first one. Let us check the first one. We can write log of A cube minus log of ABC. I think there is no problem. Similarly, we can write log of B cube minus log of ABC. Why I am giving a bracket here? Because if there is a minus sign, if there would be a minus sign here, then there would be a problem in sign, right? So I am giving a bracket for safety reasons. Log of C cube minus log of ABC. I think there is no problem till now, right? Here there is log of ABC minus log of ABC minus log of ABC. So we can write it as minus 3 log of ABC, right? And what is the remaining now? Log of A cube plus log of B cube plus log of C cube, right? When there was plus, we can multiply it, we can write it in multiplication format, right? Means, let me first write it. We can write it as A cube, B cube, C cube. How? See, log of A, B, C can be written as log of A plus log of B plus log of C. I am writing only the vice versa format right here, right? So here cube 3 to the power 3 is with all. So I can write it here 3 log ABC minus 3 log ABC. So plus 3 log ABC and minus 3 log ABC will cancel out to give the result as 0. So here log of M plus N will result to 0. I think you have understood this. So this is the most essential portion. What I have done here, I have multiplied A, and here I have multiplied A, here I have multiplied B, and here I have multiplied C. Okay, means here I have multiplied A, here I have multiplied B here, and here I have multiplied C here. Okay, I think you can understand it now. Okay, I will not write here because it may be confusing for some person. Okay, now this is one of the important problem. I think everybody those who are watching my video have heard about a exam known as WBJW, right? It is one of the most favorite question there. Okay, show that the value of log 2 to the base 10 lies between 1 by 3 and 1 by 4. Means not this question but this type of question. I will explain you here how to come to a solution. Okay, in WBGW it will not give a show that so it will give the value of log 2 to the base 10 lies between. There will be 4 options, right? So how I will do such type of problem? Now here, as we know, 8 is less than 10, right? There is no problem. So 8 means 2 cube is less than 10, right? If we take log both sides, log to the base 10, it will result to log 10 to the base 10. I think there is no problem. So here it is 3, we can check it here. 2 to the base 10, and as we know, log of a to the base a is 1, right? So log of 2 to the base 10 is less than 1 by 3. I think there is no problem here. Now similarly here there is less than 1 by 4, so I am taking 16 is less than 16 is greater than 10, right? 16 we can write it as 2 to the power 4 is greater than 10, right? If we take log here, 2 to the power 4 is greater than log 10, right? So I am taking with the base 10, so I am taking 4 here. Log 2 to the base 10 is greater than as we know, log a to the base a is 1, right? So if we take 4 this side, log 2 to the base a is greater than 1 by 4. So finally we can write it as log 2 to the base 10 is there any problem? So log 2 to the base 10 lies between 1 by 3 and 1 by 4. I think it is easy one, right? So now let us come to our next problem. This is a bit difficult problem. Okay, I am discussing you, I will discuss you. Okay, this is a bit difficult problem. So how to solve this? Let us see. So our last question is log of 2 to the base x, and we have from this question we have to find the value of x, right? It is a bit difficult question from the previous ones which we have done. So in this case, first what we have to do, first let us take log x to the base 2 equal to a. Okay, so log of 2 to the base x can be written as 1 by log of x to the base 2, right? So as we have taken log x to the base 2 is equal to a, we can write it as 1 by a, right? Similarly, log 2 to the base x by 16, it can be written as 1 by log of x by 16 to the base 2, right? So divided we can written as minus, right? When there is a divide we can write it as minus. There is no problem I think here. So here we can, as we have taken this a, here we can write it as a minus 16 means 2 to the power 4, right? So 2 to the power 4 to the base 4. Similarly a minus 4 log 2 to the base 2, and here it is 1, so we can write it as 1 by a minus a minus not 1, a minus 4. This is 1, right? So it will be a minus 4. And our last in this log of 2 to the base x by 64, right? So log of 2 to the base x by 64, that is 1 by log of x by 64 to the base 2, that is 1 by log of x to the base 2 minus log of 64 to the base 2. So x to the base 2 can be written as a, right? And 64 can be written as log of 2 to the base 2 to the power 6, right? And similarly, by like this problem we can take it at front, right? So this is 1 and the result is minus 6. Now if we substitute all these values, means log of 2 to the base x equal to a, so we are substituting here 1 by a. In this problem we are substituting 1 by a, right? So it is 1 by a into, it is log of 2 to the base x by 16, right? So log of 2 to the base x by 16 is 1 by a minus 4, and it is last is log of 2 to the base x by 64. So log of 2 to the base x by 64 is 1 by a minus 6. Now let us solve this problem. It is a if we solve this problem, so it will result as a square minus 4a is a minus 6, right? How I have got is, I think you can understand this. We have multiplied it and we have reciprocaled it. So reciprocal, while reciprocaling, we will get a square minus 4a and is equal to a minus 6. I think you can understand this, right? Now if I solve this problem, if I do middle term factorization, result to this. If I take a common, minus 2 common, it will result to this. So our result is a minus 2, a minus 3 equal to 0. So a can be 2 or a can be 3, right? As we know a, what is the value of a? A is log of x to the base 2 is a, right? And here log of x to the base 2, here it is 3. According to the solution it is like this, right? So x value is 2 to the power 2 or x value is 2 to the power 3, means x value can be 4 or x value can be 8. So this is our result. So what are the values of x? X can be 4 and x can be 8. So this is our required solution. Okay, I think you can understand this problem, right? So that's all for today. In the description I will add a PDF of the assignment of the assignments. Please try to complete the assignment, and in my next video I will discuss all the problems of the assignment. Thank you.